We are the Try Forever from Macau Pui Ching Middle School. In this modern era where technology continues to ameliorate, our goal is to create productive robots that can contribute to revolutionizing the quality of life for people. In previous years, we have gained extensive experience and reflected on our mistakes, replenishing our robot to our best abilities. Keeping the passion of trying forever, we hold an earnest and courageous attitude towards the preparation for this competition, constantly trying, innovating, and thriving for the creation of better robots. In consideration of the convenience of operators repairing and interacting with the robot, we designed and constructed it by ourselves. Also, we rearranged the distributions of each component for the completion of particular functions. Our robot's hardware structure can be generalized into the following 4 segments. On the bottom layer, connected to the chassis, is the RP-Lighter A1 laser range scanner, which is responsible for mapping the environment and navigation of the robot. Then, our motherboard, the AIX board, connecting 2 USB hubs, the open manipulator, and an Astra camera. This layer is undeniably crucial to the processing of our robot as it connects the different components on the inner portion. The lower camera on this layer assists the manipulator to gather visual information of the environment around the robot, sending raw images to neural networks, which are further translated into coordinates for the manipulator to grab accurately. The segment above that carries our battery and speaker for our power supply and the generation of sound in communicating with people. Lastly, the top layer consists of a monitor screen, the upper Astra camera, our mic, and an emergency button that cuts off the power supply to the chassis when pressed, placed next to the screen, which helps us quickly organize occurrences of danger. Using the fine-tuned YOLO V8 model, we are able to detect the luggage in the frames returned by the camera. We collected about 1,000 images of luggage and did data augmentation on them to enlarge the dataset size and to prevent overfitting, in order to achieve a better flexibility and accuracy in real tests. Using the LiDAR, cooperated with the simultaneous localization and mapping function of the chassis, we can avoid crowds of people, some hard-to-see objects, and the area blocked by retractable barriers. In the task Find My Mates, we are required to implement a person attribution recognition model. It has already existed some datasets like PETA and PA100,000 for this specific task. We used PETA dataset to fine-tune ResNet 50 model for this person attribution recognition task and achieved an F1 score of 0.875.